Hi friends, welcome back to my channel. Today we are going to solve Leetcode problem 3545 minimum deletions for at most k distinct characters. So this is another interesting recent coding problem on Leetcode. So we are going to go through this problem. We are going to go through some examples that I created so that you can completely understand this logic as well as the Java solution to solve this problem. If you are new to this channel, I would like to quickly mention that this channel is to help people in their coding interview and preparation process. On this channel, you will find more than 500 different varieties of solved coding problems that constitutes different important varieties that typically gets asked in different big companies coding interviews, such as breadth first search, depth first search, binary search trees, binary trees, graphs, matrices, different techniques such as monotonic stack, sliding window technique, as well as recursion, dynamic programming, memoization. So all different playlists are there on this channel. Please check it out. This will definitely help you in your interview preparation process. If you haven't already subscribed to this channel, please consider subscribing to this channel now. It really helps and supports this channel. So let's start with the description, then we'll go through the examples. You are given a string as consisting of lowercase English letters and integer k. Your task is to delete some, possibly none of the characters in the string so that the number of distinct characters in the resulting string is at most k. So the distinct word, you can see that they have highlighted, and at most k distinct characters should be there. Return minimum number of deletions required to achieve this. Right? So we want to find out minimum number of deletions. So let's take a look at some examples. So ABC is the given string, k is equal to 2. It means that in this string only two distinct characters can be present. So right now you can see that there are three distinct characters, right? A, B and C. So you have to remove one of them so that only two distinct characters will be present. So you can just delete C, for example, and you will get AB string which only has two distinct characters, right? So that's why answer is 1. In the second example, you will see that the string given is AABB, which means that A occurs two times, B occurs two times, and you can have maximum two distinct characters. But you will notice that in this given string, there are already only two distinct characters, right? Only A and B. So it means that you don't have to do any deletions here, right? So you will just return 0 because no deletions are required. So I created another bigger example so that you can clearly understand what they are saying. So here the string is A, B, 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 C, C and D, right? And K is equal to 2. It means that they are telling us that only two distinct characters should be present in this string, right? Only two distinct characters. So you can, for example, you can delete this A's and B's, then you will have only C, C, D, which has only two distinct characters C and D. But the number of deletions you have made here are 7, right? 4 A's and 3 B's you have deleted. So our goal is to minimize this deletion, right? We want to minimize this deletion. So how can we minimize the deletion? It means that it sounds like a greedy problem, right? So we can use a greedy approach. Why it's a greedy problem? Because we want to minimize it, right? So what you can do to solve this problem? So if you know the frequency of each of these characters in this given string, then you can decide which characters you want to delete, right? So for example, A occurs 4 times here, right? B occurs 3 times in this string, C occurs 2 times, and D occurs 1 time, correct? D occurs 1 time. So now when you want to delete characters, and you want to minimize deletions, what you should do? You should delete the characters which has least frequency, correct? I'll repeat this, least frequency, right? So that you can minimize the deletion. For example, if I want to delete first character, I will delete D, right? I will delete D. If I want to delete second character from the string, I will delete C, right? Because it has least amount of frequency. So first list is D and then second list is C. C's frequency is 2 and D's frequency is 1, and then the remaining string will have k distinct characters. Now only A and B's are there, right, in this string. And how many deletions we have made? Only 3 deletions we have made. So you will need to make minimum 3 deletions from this string, so that now your remaining string will have only k distinct characters, right? So you got the idea why it's a greedy approach, because we are greedily choosing a character, right, with least frequency. So it means that we need to find out, we need to maintain some kind of a map, right, that will tell us the character and its frequency, right? So this is the character and its frequencies, right? So this is a hash map we can prepare. We can go through this string and we can prepare a hash map that will tell us the frequency for each of these characters, right? And then but how will we identify which is the minimum frequency, right? For that, either you can use a sorting, or in this case we are going to use priority queue, right? In Java there is a class called as priority queue, which is essentially a min heap, right? Min heap. So what is heap? So min heap means it will keep the least frequency on the top, right? So these frequency is 1, right? So it will keep these frequency on the top. So let's draw a priority queue, how the priority queue will look like for this example, right? So let's say this is your priority queue, this is your front of the queue, right? This is your front of the queue. So when you put all these frequencies, we will only put the frequencies in this priority queue. So it means that we are going to put 1, 2, 3, 4 here, right? 1, 2, 3, 4 we will put. So it will keep minimum on the front, right? So you will have the priority queue will look like this. So 1, 2, 3, 4 will look like this, right? So this is the priority queue. So when you remove from the priority queue, you will get the least number first. So first you will get 1, then second you will get 2, so you will keep adding here, right? So 1 plus 2 becomes 3, so it means that you have done 3 deletions. And once you remove these two numbers or two frequencies from priority queue, then the remaining part in the priority queue, the size of the priority queue is 2, and it means that we only are left with 2 characters there, right? So one will be A, which is this 4, because A's frequency is 4, and one will be B, which frequency is 3. So this will be left in the priority queue. So as soon as you see the priority queue size is becoming equal to 2, you will stop, right? And then you will just calculate the numbers that you removed, which is frequency of the character C and D. So total will be 3, and that's what will be your answer, right? So this is how you can solve this problem. So priority queue will take n log n time for storing it, right? So I'm going to now show you the code, so you will understand how to write this in Java. So first we will create a this frequency map using a hash map that will store the character as a key and the frequency as the value, right? We will take all the values, these all the values we will take from this map, we'll put it into priority queue, which is a min heap. So minimum value will be on the top, right? And then we will just remove those frequencies from the top until the size of the priority queue becomes this given k value, right? It means that only those k characters will be left basically in the string. For example, once you remove D and C, then only A and B, which are two distinct characters, will be left in the string, and we have done minimum deletions here, right? So this is how you can approach and solve this problem. So let's take a look at the Java code, so it will be more clear for you. So first we will just initialize one count variable. So string s and k values are given to us. We will create a hash map with character and integer. So here I'll just write down a comment for you. So here the key is the character, right, that we are reading, and the value here will be the frequency, right? Frequency of the character, right? So we are now going to go through the character array for that given word. s.toChar array method we will use, and we will create our frequency map for that characters here, right? So frequency, so for that character you will just check if frequency map dot get or default. So it means that if there is no entry, it will take 0, otherwise it will use the existing frequency and increment it by 1, correct? So that because we want to calculate frequency of each character. Here we have created a min heap priority queue that is going to hold integers. Why integer? Because we are going to only store frequencies here, right? We don't need characters, because we want to only return number of deletions, which is integer here. You can see that we are returning int, right? Here we are going to take all the values which are frequencies from the frequency map that we have prepared, and we are going to add that into our priority queue. This while loop, we are going to iterate through the priority queue until its size is more than k, and we are going to keep removing those frequencies. For example, here we will first remove 1, then 2, and once you remove 2, the size of the priority queue becomes 2, right? Because now only 3 and 4 will be present, which is equal to this value k where you will stop. So that is what we are doing. So while pq dot size is greater than k, you will keep polling. Polling means it will remove the value from priority queue. You will add it into your counter, you will increment the counter, and at the end you will just return the counter. The count will signify how many deletions you have made actually, correct? So let us give it a run. So and make sure all the test cases pass. I created a test case for this example that I shown you here. So this is our test case that we just have seen. So you can see that the output is matching the expected output. So we are going to submit this code to the Leetcode, make sure it gets accepted by the Leetcode, and as you can see, the code got accepted by the Leetcode here. So this is how you can use a greedy approach to solve this problem: 35-45 minimum deletions for at most k distinct characters. Another interesting coding problem on Leetcode that I wanted to explain it to you and explain the logic so that you can completely understand how we can use the frequency map logic as well as the priority queue min heap logic here to solve this coding problem. So I hope you clearly understood this solution, the Java solution, and you like this video. If you like this video, then please give it a thumbs up, give it a like to this video, share this video with all your friends and colleagues so they can also watch these videos. This really supports the channel. On this channel, if you haven't already checked the playlist, there are more than 500 different varieties of solved coding problems available here that you can use to prepare well for your coding rounds. The varieties of the problems consist of BFS, DFS, graph problems, binary tree, binary search tree problems, array and string related coding problems, problems that uses recursion, dynamic programming, and memoization. So everything is available. Please make sure you check out the playlist and subscribe to this channel. Your subscriptions are very much helpful for the channel. And one other thing is we also quickly wanted to see the algorithmic analysis here. So the priority queue uses n log n logic to keep the minimum elements on the top. So n log n will be the complexity for priority queue. We have used the frequency map, which will maximum n will be the size for that we have used here, and priority queue also can take a maximum n size, right, as a um, space complexity. So thanks a lot for watching this video and have a great day ahead.